Okay, so this is a recording for the week of March 28th. So a couple things of note. The first thing is that going into next week, and I'll send an email pertaining to this, beginning next week, you guys will be back into groups. So be mindful of who's in your groups. I've redistributed everybody and put you guys in the new groups because of some issues that we were encountering. So hopefully everything should be okay. If you have a communication issue or you're not able to meet at a given time, let me know. I believe most of you guys are able to chat online at various times. So you don't necessarily have to meet. You guys could still work virtually, assign who's going to be doing what, and then work from there. So let me share my screen with you real quick. And while I'm sharing my screen, I do want you to note that this next assignment, which we'll talk about again, is in group. But this week, for March the 28th, your assignment is an individual assignment. So the way you're going to see who's in your group, you're going to go into the Communicate tab and then Groups. So right now I'm in as a student, and I've signed myself up into group number 1. So if by chance I don't get to pulling myself out because I may get distracted here, just note that this demo student, SBC demo, is me. So so group number 1, here you guys are, Ruffner, Botsworth, Gray, and Dubose. You guys will be working this next round, beginning again next week. The assignment will be due the following week. So let me stop the share here. Let me pause for a second, and I'm going to switch over to the content area. So in the content area, again, here are the projects that we've done, the experiments that we've done. And so this week, we're going to be looking at an inelastic collision, which will be due the following week as normal. And just again, to reiterate, you guys will be working for the remainder of the session, beginning April 6th, or that week thereof, on these final 3 experiments. So simple pendulum, torque, and simple harmonic motion. And just to give you a preview of things to come, we're going to be reviewing the lab final on the 27th. I'll be doing it with my class that week. So if you want to tune in with us live, you can, but I'll be sending off the recording the following day, probably here on the 29th. And your final is going to be on the 4th, or the week thereof. Since this is an asynchronous class, if you are listening to this and you are not in the live online class, your final is up until that Saturday, thereof, so May 6th. And I submit grades, that would be May 12th. So let me pause one more time. And so looking again back at our next experiment, remember, you may see the numbering slightly off. So we're in experiment 9, but this is week 10. So you should know, I'm sure you guys know where to find this document under course content. And I'll move it up a little bit so you can see it in the table of contents off to the right if you happen to see this at an earlier time. But anyway, so same simulation or simulator, which is over here to the right. And so I'll go through this simultaneously. So you will open up the lab that says Explorer 1D, probably the best one. Well, we can do inelastic. Inelastic is just as good. And we're going to hit the reflection border, and we're going to check the appropriate boxes. And remember, what we're going to be looking for here is we're going to be looking for the final velocity of the pink ball or the red ball, however you want to interpret it, turquoise ball, the kinetic energy initial final, the momentum initial final. I'm also going to want you to draw the before and after collisions, and you're going to use the momentum as the vector. So on the right side here, let's get rid of velocity. Velocity and momentum are proportional, but they're not exactly the same. And we're really going to be in one dimension. So you can do this one of two ways. Let's see, I believe you can customize it to set up so that it stays in one dimension just by clicking here. If we hit more data, you can see that the y-axis is set at 0. I don't think you can, well, I guess you can vary off that. So just by clicking this little icon here, this implies that you're going to be staying in one dimension, and that being, we can call it the x-axis. Okay, so you don't want a reflecting border on, kinetic energy you definitely want on, and you want to see some values here. Now, I may have said this last time, but remember that the values that the simulators are giving us are in terms of an absolute value. We want to really be mindful of the direction that things are going in. So just keep in mind that this v vector, probably for the one on the right, if I were to write this in the vector notation form, would have a negative 0.5 meters per second and probably an I hat. And likewise for the momentum. So just be mindful of that. Let's see, the path, I'm not too worried about the path, and I think we should be able to go from here. So we also say here you may need to reposition the balls. If so, make sure that the Y position is set at 0. Otherwise, you'll be looking for an additional dimension. And so, you know, the fast way of making that stay at 0 is simply to click that button here, and this kind of triggers it and switches it back to 0. All right, so let's do one of these. So for the turquoise ball, I'm going to set the mass at 0.5, which it's set at. For the pink ball, I'm going to set this at 1.3. I want the velocity, the initial velocity of the turquoise ball to be positive 3. So positive is to the right, and the pink ball, negative 0.5. So let's see, the turquoise ball initial velocity is positive 3. And then the pink ball, we want its initial velocity to be negative 0.5, which it is. Okay, so let me kind of move this because I'm going to want a collision to occur given these initial conditions. And again, remember when we move things, this thing kind of happens and whoops, this thing switches back. So we have to be, I'll show you another way of fixing that. So let's go back and do this one more time. This is good practice. So turquoise ball 0.5 in terms of its mass, pink ball 1.3 in terms of its mass. The initial velocity of the turquoise ball we want to be 3, positive 3. The pink ball we want to be negative 0.5. So again, we can let this run as is, but I typically like to see sort of a gap here. Right? And last time we figured out that if we move it slightly, we're going to cause this thing to reset. So what we can do is just set each one of those Y values to 0. And then that way we can ensure that it stays in one dimension. All right. So if initially the initial conditions don't call for a collision to occur, you're going to need to readjust these. All right. So the first thing we're going to note here is the initial kinetic energy. So given these conditions, we should be able to find, we should be able to calculate the kinetic energy of the system. I'll do it quickly on the board at the tail end of this. And I'll set this at slow. And so let's see what happens. So they're running into one another. Bam, we get a collision. They stick together. And now I'm going to see a couple of things that happen. So first thing I noted was the kinetic energy now went from 0.2 down to, sorry, it went from whatever, I didn't write down the initial kinetic energy, we'll set that back, but it went all the way down to 0.2 joules. So this whole thing is going to be moving off to the right with a velocity of 0.47 meters per second, and the momentum is 0.6 kilogram meters per second. Okay, and so let's reset that one more time. Let's see, we can reset it here. Or let's see, we can set the turquoise at 3. We can set the pink at negative 0.5 initially. Pink. And so remember, this is slightly off here. We don't want those to be off the x-axis, so we set it at 0. So you can see here that the initial kinetic energy dipped all the way down from 2.4 down to 0.2 joules. So you're going to want to take that information and make sure you are able to put that in each one of the trials. So each one of these things is going to change. The total momentum of the system is what we're looking for in each one of these. And to figure that out, you'll add the momentum. So a 1.5 minus a 0.65 gives us a, let's see, that 8.5. Do this real quick. 1.5 minus 0.65. Yeah, so 0.85 is the momentum before. We run them together, they collide. Notice the momentum does not change. It stays at 0.85. So we take the sum total of those values. If it's negative, we have to subtract out. Okay? And so you're going to make sure that you draw a picture. Right? So in this situation here, you're going to draw a picture of the momentum before and after. So the before picture, I'm not looking for any screenshots. You're going to want to kind of reset this to go back to what the initial conditions were. Obviously, these aren't what the initial conditions are. You're going to do that for each one of these. You should start to notice some things here that are consistent. Some are consistent with the elastic collision, some are not. Okay, so if you have any questions, feel free to give me a call, 791-2503, or shoot me an email. Take care.